Hello and welcome to the video on even and odd functions. So let's talk about an even function first. Graphically, an even function is symmetric across the y-axis. Okay, so think about a parabola. And if you think about the equation y equals x squared, this is an example of an even function. Okay, it is symmetric across the y-axis, which means the y-axis is actually a line of symmetry. Okay, now just a quick note, if I were to shift or translate the parabola either left or right, so let's say I put it over here, this would not be even because I would not have the y-axis as the line of symmetry. So even functions are pretty straightforward. Visually, they can just be folded across the y-axis. Another famous example is the absolute value function, again, centered at the origin so that they could be folded over the y-axis. Okay, now, some functions may be a little more complicated to tell. So there's an algebraic test. To be an even function, we need to know that f of x is equal to f of negative x. So what do I mean by that? Okay, what you're going to do is you're going to take the equation of the function. So f of x equals x squared, and you're going to test it using some x values. Now, when I test the function, I never use 0 because that's not going to give me too much information. I typically use easy numbers like 1, 2, or 3. So let's use the number 3, okay? What this means is I'm going to plug 3 in for x here and here and evaluate. So what's f of 3? That means I substitute 3 in for the function. F of 3 is equal to 9, okay? Well, now it says f of negative x, okay? So I'm going to say, well, what's f of negative 3? And I'm going to carefully substitute. Remember, when you substitute, you have to use parentheses. So negative 3 quantity squared is also 9. So that means since f of 3 equals f of negative 3, algebraically, this is an even function. In the next video, I will talk about how to determine if a function is odd.